Welcome to this first lecture on structural equation modeling. In this lecture, I'll be giving you a brief introduction about what is structural equation modeling. To start with, what is structural equation modeling? Structural equation modeling is a multivariate data analysis technique. It is generally used to statistically model relationship among variables. SEM is SEM as structural equation modeling is commonly known as is a confirmatory data analysis technique. It 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 means that it tests the models that are conceptually derived beforehand, and it tests if the theory fits the data. SEM can be thought of as a combination of factor analysis and multiple regression. It can simultaneously test measurement and structural relationship among the variables. SEM is a family of related procedure. It is alternately defined by the following terms. It is also known as path analysis, path modeling, causal modeling, analysis of covariance structures, latent variable analysis, linear structural relations, etc. So, what is at the heart of SEM? So, the underlying statistical analysis or underlying statistical concept that runs behind SEM is covariance. Covariance can be defined as a measure of how much two random variables change together. Alternately, it can be defined as the strength of association between two variables and their variabilities. So the basic statistics of SCM is understanding the pattern of correlation among variables and explain as much of their variance as possible with the model specified. So when we are running the SCM analysis, we are trying to understand the pattern of correlations among a set of variable and how much of their variance can be explained with the specified model. Okay, so what is the logic behind SCM? Okay, so every theory implies a set of correlations. Variables, they are correlated. One variable is causing another. So there is a correlation among variables. But the necessary but not sufficient condition for validity of theory is that it should be able to produce the correlations that actually observed. Okay, so in when we are running SEM analysis, we are testing if the implied covariance matrix is equal to the actual covariance matrix. Okay, so as I mentioned in 2 or 3 slides back, that SEM analysis can be thought of as a combination of factor analysis and regression analysis. So why do we prefer, why do we use SEM analysis when regression analysis is already there? Okay, the reason being that SEM allows only the regression analysis allows a single dependent variable, whereas in SEM analysis we can have multiple dependent variables. Secondly, the SEM analysis allows variables, the independent variables, to correlate, whereas in regression, one of the assumptions is that the independent variables have to be independent of each other. Lastly, in regression analysis, we assume that there exists a perfect measurement, whereas in SEM analysis, we account for measurement models. So we will be covering about measurement models and measurement errors later on in this session. Okay, so what are the uses of SEM analysis? SEM analysis is commonly used for testing the theory. It is used for testing the prediction association prediction or association in the model with the multiple dependent variables. It is used in testing the model fit, if the theory is fitting the data. It is used in testing the effect of the indirect effect or the mediation effect of one variable on a relationship. Okay, we can use SEM analysis to make group comparisons. We can use SEM for longitudinal models, and we can use SEM for multi-level nested models. Okay, so if you are looking for online SEM training, do contact us at info@costars.com.